Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Now that we've seen what the parent rational function looks like, let's talk transformations. So if we want to transform our function, we can use it using four possibilities. Let's go through each one of these. The first one is A. So this first is the general form of transformations for any function family. So I'm going to quickly go through this. The A value is your vertical dilation or reflection over the x-axis. The next spot is the B value. The B value, the B location, essentially is horizontal dilations or it reflects over the y-axis. Now the good news about B is, to be honest with you, we rarely use this transformation until we get to the trigonometric function family, which won't be until second semester, so don't sweat it about B. The next one is going to be C. The C value, or C location, is horizontal translations. That's your left and right. Last but not least is the D value. The D value represents your vertical translations. So this is basically your general form for any function family, okay? Make sure this is clear in your notes because we're going to refer back to this for the entire school year, okay, including second semester. Now, we're studying rational functions though, right? So how does this form apply to rational functions? Well, here you go. This is the general structure of transformations for rational functions. So your A value is typically on top, although if it's a negative, it could be out front. The B value is usually in the denominator, but it's super important to notice that the B value does need to be factored out to be revealed. Now, like I said before, we're not going to focus on that this much in this semester, so don't stress. The next is the C value. Remember, the C value is going to give you horizontal translation, so you're going to find that in the denominator part of your rational function. Lastly is the D value. This is your vertical translations. Notice it's going to be outside of your actual fraction. I want to point out something. When you do the D value, if D is positive, you will go up. If the D value is negative, it will move down. The opposite is true for C. If the C value is positive, you will actually move to the right, but what will happen is inside it'll look like this. If the C value is negative, you will actually move to the left, and the denominator will look like that. So in other words, for the C value, you have to think of the opposite sign of what you see.